I win.
No. J win.
Oh, I get it. Does J get it?
Velocity, yeah. So as you can tell from that joke, that was a terrible I and J component joke.
Yep, absolutely. So when you have a velocity in a direction,
Mm-hmm.
you always have velocity in a direction because it's a vector.
That's how velocity works.
It can be divided up into its horizontal and its vertical components.
Yep, and we now denote, that's what I was looking for, horizontal with I.
And the vertical with J. So J for jump is how I think of it. So this
And
would be
I
J.
like to go sideways. So if I then say that it was 3 that way and 4 that way.
Yep. That means in this triangle, this would be 3, this would be 4, and
And
by
then
Pythagoras, because this is a right angle.
Working that would be 5.
Absolutely. So this is all what we did in the displacement video. So if you haven't watched that, you should watch that because that familiarises you with the I and J. So we'll give you a minute.
Yep. I'm not wearing a watch.
I am. Hasn't quite been a minute, but we'll get it on.
I think we're going to, yeah.
So we know what I and J means. It's the horizontal and vertical components of a vector.
So I think the best way to really explain how to do these sort of questions is to do a sort of question.
And they love boats crossing rivers.
They do when people are swimming in ducks and planes.
And planes in the wind and stuff like that.
And stuff like that. Yeah, kites.
So I take off from one side of a river.
Oh, okay. There's going to be a plane then taking off.
And I want to get to the other side of the river.
Right.
Sort of here.
Because there's a McDonald's there, I
There's a
presume.
McDonald's, there's always a McDonald's. Now let's ignore the other side for now. Let's just say I'm going,
Okay.
I've got an upwards velocity, up across the river,
Right.
perpendicular to the motion of the river, of, let's say, 3I plus 5J.
Okay.
Who knows?
Who knows?
And the river itself also has a current, so as my boat goes up, the current's going to push my boat that way as I go up.
Yeah.
And the current has a velocity of much smaller, let's say 0.2I plus 0.5J.
Right.
And what if I wanted to work out the resultant velocity?
Well, you work at resultant velocity in a similar way that they've been working out before.
Yes, so the same as what we did with displacement, because they're in both in terms of I and J.
Yeah.
What we could do is make them into awkward triangles and try and resolve them from there.
But it's easier just to straight up add them, so I will do that.
Yeah. So we get 3I plus 5J,
Yeah.
but we're now adding the I and J components. So 3 plus 0.2 is 3.2I, and 5 plus 0.5 is 5.5J. And that is a normal, typical start to a question if it's in terms of I and J. They don't stop there. If they say that's the resultant velocity, as my boat is going sideways and forwards, what if they ask for the angle I make to the bank?
They could do that.
I'm actually going in this direction.
Yeah.
Hopefully you can see that by this going up and this going up. But
Yeah.
altogether I'm going to be going that direction.
I mean, that would be true from your speed anyway, but yes.
Yep. So what is the angle here to the horizontal bank, this theta?
Okay.
And what we sort of need to do is rearrange these lines to make a neat triangle, I think.
Yeah, we can do. So, yeah, there's two different colours, so that works fine.
Or we can just treat this actually, we can just use this. I forgot we could just use this.
Let's do that.
That's a really useful
That's
thing to do.
better.
I was going to make that really blooming awkward. This is our resultant,
Yeah,
so
and
it's
then
going in this direction.
And then we got a triangle
So
there.
let's take this line out for a second. There we go. Nicely done.
Ta-da. So that would be this whole thing, but that means that this line,
It's 3.2 going east because it's positive, and 5.5 going north because again it's positive, so we've got 5.5 coming up. The right angle is here, and the angle we're trying to find out is here.
so, like before, we're going to use tan, or before in a video that you haven't seen, or might seen.
Because we've got opposite and we've got adjacent.
So-
So tan theta equals opposite over adjacent, so tan theta equals 5.5 over 3.2, just like that. So theta, the angle it makes to the bank, is 10 to the minus 1 of 5.5 over 3.2, which I cannot do in my head. I wish I could. 10 to the minus 1 of that will give you the angle to the bank, and that's another typical question they can ask.
Yeah.
Then what they might do from them, this is sort of bringing everything together, is they might tell you the width of the bank from here to here
Okay, and then they'll
in
ask you,
metres.
how long will it take to get there?
Yeah, or what's the distance that you actually travel? If this is this, and you're now travelling this way, what you can do is you can work out that angle because you know that angle.
Yeah.
So it would be 90 minus that to find out this. then you can use this, which you know, to find out the distance there,
Mhm.
stuff like that. It's just using triangle stuff from GCSE and sort of thinking about the question. It's typically how they start it, find out
Yeah.
the resultant, then find out the angle.
Okay.
And that's velocity in a nutshell.
Yeah. Acceleration is quite similar, but we'll go on to that next.
Yeah.
Anyway.
So we'll see you in that video as well.
Yeah.
Bye.